Hello. If you watch my channel, you'll know that this machine broke down on me the other day. It's a Philips VR2324 of the V2000 videocassette format with reversible tapes. And this is one I'd worked on a little while ago, and has been a good machine. But it seems to have developed a fault, and it sounds like it's tripping. The power supply keeps shutting down. So let's have a look and see if we can work out what the problem is. I may have a scrap machine somewhere, but right now I can't put my hands on it anyway. So let's just see if I can make some progress with the power supply, which is presumably where the fault lies. Let's start by just demonstrating the problem. So I switch it on. Interesting, that's even weirder than the other day. It's not on at all now, and when I picked it up it started clicking. Could it be a bad connection type fault? Because the display should light up. Power on button, nothing. How interesting. Okay. The power supply has a sense resistor and an op-amp to detect an overvoltage condition over that 0.11 ohm resistor, which is in the power supply up in this corner. So I'm going to have a look and see if there's a good input voltage to that, and then we can the input voltage to the regulator, and then we can have a look at if there's any output voltage and get a feel for whether this trip circuit is firing. It's interesting how it's got much worse. It started out with just a very occasional click and shutdown, and now it won't fire up at all. Right, we're looking down on the machine here. The deck's to the right. The power supply is integrated with various other functions, including tuner, which is just unhelpful. It makes it very hard to just swap out the power supply. So the part we're particularly interested in is there's a op-amp which is associated with this current sense resistor. So there's the op-amp in there, and the resistor is somewhere around here. We'll have to find that in a moment. The transistor that provides a 12-volt line takes 21 volts in. Need to find that transistor. It might be this one, but we'll check that in a minute. And that's being shut down potentially by overcurrent. So we need to check that there's a voltage into that, and that we're not getting a voltage out in the fault condition anyway, and then trace back where the fault is originating. I should say schematics such as they are one, not mainly written in English, and two, not actually for this model, so it's always a bit challenging making sense of the schematics on this. Okay, having looked through the schematics, this is our transistor, which does the 12-volt regulator. This is a diode pack, so the output from the diode pack, which is on the center pin there, appears at pin 3 of this connector here and goes up to the red wire on the transistor, if I can get to that. So that's the emitter of the PNP transistor, and that should be about 20 volts. So we need to pick up a good ground and just confirm that that is 20 volts there, 21 volts, something like that. Let's switch to the volts. So even in the non-working condition, we hopefully will get 21 volts there. Okay, so even in the non-working condition, I'm expecting to see about 21 volts there. Power it up. And now the machine works. I don't have the voltage I was expecting to see there. Why am I not seeing that? Okay, do that again. So we should have 21 volts in. I'm getting that. I don't know why it came and went a few times there. And 22 volts in, that's good. Let's look at the output of the regulator, which will be the 12-volt line. So that's going to be the collector of this transistor. Okay, so 12 volts there. Came and went a bit. Let's put a tape in. Oh, it went down again. Didn't ask for that. Press play. And it's working. Okay, well, I'll leave it playing for a while. Actually, I'll put a different tape in. This one's a bit short. I'll just hook it up to a TV by one means or another. I could use this weird connector here, which a lot of Grundigs used. This has got a SCART socket, but it's also got this DIN connector arrangement that other V2000s had. Did you see that? It was on and off, and now it started working again. Highly intermittent fault. Let's try to look at the voltage across that sense resistor, because if that's rising, then there may be either an overload or a bad resistor. So let's switch the machine off for a moment and hook that up. First thing I want to know is what the resistance is. It should be 0.11 ohms, and I can't isolate the resistor terribly easily, not fully anyway. But if I unplug the transistor from here, if I can do that, then that isolates that part of the circuit, and see if I can measure 0.11 ohms ish across the resistor, which is number 3020, and so that appears where? Over here, not far from this connector. Okay, it's that big green resistor there, so I'll need to put some hooks on that to measure it. Right, let's do that. Let's measure that resistance. We can start by just trying it on with a multimeter, but it's going to be quite hard to make a good enough contact, because even a fraction of an ohm is going to make a big difference. Right, okay, that's the transistor unplugged. Reading 0.22 ohms. Right, let's zero out the meter. Best I can get is about 0.05 across that. So we need to take about 0.05 off the reading. Does that get us to 0.11? Yes, it probably does, doesn't it? So it's supposed to be 0.11, and we've got about 0.05 on the meters, so we're reading about 0.1 ohms. So I don't think the resistor's gone high value. So I'd say the first thing we need to do is measure the voltage across that. Now we have the question, what voltage should be across it? And I don't think that's specified, unfortunately. And we don't know what the current load is. But whatever the voltage is, it should be small enough that the op-amp does not cause its output to go down and thereby switch off the diode on its output and then go through the process of this voltage falling and switching off the regulator. So let's measure that voltage and see if maybe we can get some readings when the machine is running and when the machine is in the tripping sort of condition or about to trip, and we'll get a feel for whether that voltage is rising. If it's rising a lot in the fault condition, we could have a genuine overload. 0.1 something volts then, let's go into play. 0.1, it peaked at about 0.2 volts. I'm using picture search. And it's sitting around 0.13 volts, something like that. Well, it's still running just fine. I notice if I select certain functions that current can go up a bit to around about 200 or so millivolts, and that seems to be normal operation. So it appears to be the circuit's a bit oversensitive. Look, it's going over 200 and that's not triggering it, so why is it occasionally just freaking out and switching down? I'm thinking of possibly, one, take the board out and resolder everything around there, and secondly, maybe I might add a small capacitor across the sense resistor, just to maybe reduce the speed it actuates at. Look, over 200 millivolts there under normal operation. Okay, the machine's now been working flawlessly for about 6 hours, so that's a little unhelpful. The fault has gone away. Is it because I've connected the multimeter to that resistor? Is it because I've disturbed the connections on the top of these? Well, that's a transistor, that's a rectifier, and these two are regulators. I think I will take all of those off and clean the pins. Is it because of the capacitance of the multimeter? Well, I'm thinking of putting something like a 0.1 microfarad capacitor, or something like that, maybe a little bit bigger, across that resistor. Mind you, what kind of time constant is this low value capacitor going to have against a 0.11 ohm resistor? Maybe it won't make any difference. I'm not that keen on taking the board out, but I may have to. Looking in here, look, this looks absolutely mad, doesn't it? There's a resistor on a header plugged into the board. It looks absolutely nuts. That's a resistor that you can select the value of in order to set the correct voltage. I think it's on the 12 volt line. What a strange arrangement. I think really to be sure this is done, I'm going to have to take the whole board out again, which means taking this heatsink off and loads of other bits is an absolute nuisance. And make sure all the soldering's good around the op amp that is used for detecting overcurrent. And I may add some extra wiring to the bottom of the board to make sure that the tracks are as low resistance as possible. That's all a bit time consuming, but it'll be fine as long as nobody interrupts me.
Dad, what? My headset won't charge.
What? No other YouTuber has to put up with this. What's wrong?
The headset won't charge when plugged in with a USB cable.
Right. I'll fix that in another video. Okay, let's disconnect our multimeter from this current sense resistor. And just out of curiosity, see if it now works. It's not tripping at all now. So I'm going to clean up the connectors on the back of all of these transistors. Well, I'm still in two minds. Do I take the board out? I think I should, and I'll check the soldering, especially around that resistor. Yeah, let's go the whole hog. There are screws on the transformer, which is mounted to the side here. So we need to take the transformer off. Big heavy lump. So I've disconnected those cables. I think I may have to disconnect some more. Right, that's disconnected all the wiring off this board. So now I can get to everything. This is our sense resistor down here, so I'm going to check all the soldering around there. I may add a small capacitor, but if I do so, I'll add it to the top so I can cut it off later without taking the whole board out. And I'll also clean up all the contacts on these regulators and transistors and rectifiers along here. So our sense resistor is 3020 on the diagram, which is near the socket. There's the socket, so it's in this area. So our resistor, R3020, is mounted here. So this is one end of it. And I'll get it clearer. So that's one end of it there. This is the main connection to the down to this socket F12, but you'll also see our sense wire coming off here down to the op amp that does the check for overcurrent. And the other end of the resistor, so I'm moving the board across, so this is one terminal. Ignore these two, that's a link underneath the resistor. Here's the other end of the resistor, and again that goes to some big heavy tracks, and also, as you can see, a sense wire. So is the soldering good on this resistor? Well, I wouldn't describe it as good, and bearing in mind we're looking for some pretty small voltages across this, so a small amount of resistance could cause a problem. So I'll resolder that. I'll also resolder at the other end, and where it connects to the connector here, which all looks a little bit, they all look a bit crystally, and the op amp that does the overcurrent is here, and again all the connections on that look a little bit crystallized, so all of that could use resoldering. Okay, I've resoldered all of the circuitry around there, and the other thing I'm going to do is look at the regulators and transistors around here, just clean up those contacts as well. So I'll clean all of those with a fibre pen. And a little deoxit in these. This isn't the easiest stuff to get in the UK. Very important, of course, to refit these connectors very carefully. I'll blow some dust out of it, and there was a dead spider in there earlier as well. I'll blow all of this area with some compressed air and then refit it. Okay, that's ready to be refitted. I've decided against fitting a capacitor across that resistor, because what difference is something like a 0.22 microfarad capacitor going to make when there's a 0.11 ohm resistor across it? I don't think it's going to make any measurable difference at the sort of frequencies we're looking at. Right, I'll refit that shortly. Right, let's see if it runs. No, we have a problem. I can't plug the SCART lead back in. It seems the PCB must be a tiny fraction too far that way. Let's slacken off the screws. I think I'm going to have to take all the screws completely out and joggle the PCB back into place. Yes, it wasn't that way, it was that way. Right, I can refit the SCART lead now. So with that being in the correct place, I should be able to do up the screws. I have to say the screws on the cabinet work, I've never really felt that they're that convincing on this model. They could have done better quality screw holes, I think. Okay, let's plug it in and see what it does. So far so good. Right, good. I'll tidy up some of this cabling a little bit, and then I'll refit the top lid and test it. What I'll do is I will set the clock, which I must say I actually quite like the clock on this one compared to earlier models that I really used to use. So if I set the clock on there, if it glitches, I'll know when I come back in a few hours, because I'll see the clock flashing. So long as the clock's still on, I know that it's been working. So I'll rewind this tape to the beginning. It's that long one of Hitchhiker's Guide to the Galaxy, and I'll leave it playing for a few hours. I think that's fixed. This has been running now for 8, 9, 10 hours, not skipped a beat. So I think we can safely say that's fixed. But what was it? It was some sort of contact problem. I suspect it was on the transistors or regulators at the back, which I cleaned up. I can jiggle it about now, and obviously no more disturbance than you'd expect from knocking a video recorder around. Do you remember when I did the last video, I looked at the VR2023 and I said the picture's a bit noisy? Well, let's freeze frame this and have a look at the noise on the same tape on this machine. There's just as much noise on this, so it's not down to the other machine having any kind of defect that's causing a noise issue. Now the interesting thing about that is that the noise is variable. You can see noise even in freeze frame. That eliminates any possibility of the noise having been recorded on the tape, because in freeze frame the noise would all become stationary. So what it's saying is one or two things. Either the tape is a bit worn, it has a low RF output, so the head amplifiers are increasing the gain. That's normal, that's what happens on video recorders, right? So they are raising the noise level as they increase the gain as a result of the tape being worn. Other possibilities are expectations that a 1982 or whatever it is video recorder does have a relatively noisy image, especially a V2000 one. I think the V2000 format has a significantly noisier picture, especially compared to beta of the same vintage. There are people who love V2000, but I've never been that impressed with the picture quality personally. But anyway, I think we can safely say that that's a fully working machine, and so is the VR2023. I just need to sort out the battery issue with that. The parts have now turned up for us to finish this V2000 video recorder, the VR2023. This is the one where it's all working now, but the internal battery, these always need replacing. They're a bit hard to get, these original types. That's 1/3 AA, 3 of them, with solder tags soldered together. It'd be expensive to buy that, so I've decided to buy 1/3 AAAs. These are readily available, and a AAA battery holder. Hopefully they will all fit together there and we won't run out of space. Let's find out. Now I'm considering heat shrinking them, but on the other hand maybe that will impair their ability to stay together. So let's just see how we go if we just sit them in a row in here. Or we're going to run out of space. Looks like we're going to run out of space. So the problem being that they're 1/3 AAA in body length, but they have the end terminal, and I think that's going to be too big to fit. Oh, what a nuisance. It was a good idea, but they're not going to fit. I could file the ends, perhaps. Is that going to give me the room I need? Would a AA holder have been better? I have a 2 AA holder here. Let's just try this, see what it looks like. Well, there is the difficulty that the batteries could slop a bit, but I think that might be a better solution. So we'll replace that with a single AA holder. Well, here we are a few days later, and we have some AA battery holders. So I'm going to see if I can put the 3 AAA third batteries in there. So these are the batteries. I think they're commonly used for lights, solar lights. Now if I just pop them in, I think that would work, but they'd slop around a bit side to side, so I need to provide some filler material, I think. But, oh yeah, that's looking really quite good actually. Let's see if we can measure a voltage at the terminals. Right, let's go across the terminals. Yes, 3.7 volts. Good. What I'm going to do is put a little bit of plastic packing in there from some scrap plastic to keep the cells from slopping around. Okay, I've just found some plastic packing from, actually it was left over from installing a motherboard recently, and So that's all good electrically, but I'll pop that heat shrink over the top and shrink that on so that the batteries can't slop about. The original battery was AA size and actually consisted of 3 of these. I managed to find one to demonstrate. And the key thing to notice here is that the smaller terminal there is negative and the wider one is positive. So on the board we have a small slot and a wide slot, so that's positive. So need to mount it that way around. I'm going to fit the battery holder using some decent quality sticky pads, not the things you pick up from the pound shop, because they just don't stick. Need to be mindful of going too far down because we might collide with the top side of the edge connector for the bottom. Okay, I've written on there, it's not easy to see, but I've written on there the date I've fitted them. So that's, I'll just do one more voltage check, make sure that's all working. 3.7 volts, ideal. Okay, if I've done everything right, it will work. I'm not sure why it just went into play mode. That was slightly odd. I pressed the button expecting something to happen there. I obviously got my head in the VR2324 mode where it goes down under motor control. There's something else going on here. I don't know if you can see it, but that says 75. Why does that say 75? Reset. Oh, okay, that's fine now. That's not progressing. That's a fault I had at the beginning. But when I had that fault at the beginning, as well as not progressing, the machine would shut down every few seconds. Now, oh, it started working. So there's something a little bit temperamental about the tape counter. It's working now. So it's just a sound problem. What's going on? Just a moment, I may have had the cables plugged in incorrectly. Yes, I did. This is that weird adapter cable necessary from that stupid DIN plug thing going on. Okay, that's good enough. Let's put it back together. Before putting the top on fully, I need to remember, of course, to refit the screws for the front panel to stop that swinging out. Okay, that's fully reassembled. Let's test it. A nice feature is that when you reintroduce power to it, it will have the original time still stored on the clock from when it was last powered down, which, well, it'd be better even still if it kept time, but it doesn't. But at least it's only going to be as slow as the power outage was. Okay, that's all reassembled. Let's check it works. Oh, good. Now, this is a Signal X Poundland remote control. I featured these on my channel many years ago. They're really handy because they include a lot of codes for obsolete products like this. And the first code I tried for Philips VCR was 0460, and straight away that worked. So really handy thing to have with these machines that have the remote control sensor. If anybody has this cosmetic panel, a spare one of those lying around, do let me know. I couldn't seem to find mine. One of the hinges is broken, so there's one little hinge in place and the other one's snapped. So I could use a front panel and one of those hinges, and that would set this machine off nicely. It would look as good as it works. Okay, I'll do plenty more content on audio and video technology in the near future. Bye for now.